Hey, this is a Miss Albin's physics video that will cover some of the basics behind free fall. So first, it is useful to define free fall. Free fall is when an object is falling and only falls under the influence or pull of gravity. This means that there are no other forces, such as air resistance, pushing up on the object. So we all know what it's like for an object to be in free fall. Say, for example, you're standing at the top of a cliff and you drop a ball. It will gain speed as it nears the ground. When an object is in free fall, during each second of falling, the object gains a speed of 10 meters per second. So if we drop something from rest, in 1 second of falling, it is falling at 10 meters per second, and after 2 seconds of falling, it's falling at 20 meters per second, and after 3 seconds of falling, it's falling at 30 meters per second, and so forth. This increase of 10 meters per second of falling is the acceleration due to gravity. Technically, gravity is equal to 9.81 meters per second squared, but for our calculations, it's often easier just to round to 10 meters per second squared. Since there is an increase in velocity, we know there is an acceleration. When we say that something increases 10 meters per second every 1 second, our equation can look something like this. And we know that we can simplify this division of seconds, and we see that we just simply end up with 10 meters per second squared, which may look familiar. You may be asked to find the velocity of a falling object after a certain amount of time. So we know that the acceleration is the change in velocity over the change in time. We can simplify this equation to make it more geared towards free fall. For example, we know that the acceleration of the object will be equal to 10 meters per second squared, which we will represent with a lowercase g for gravity. We also know that if we drop something at rest, the initial velocity is going to be 0. So we can plug in these values, and we can solve for the final velocity, which is just simply gravity times time. This equation makes sense. If you recall from the mental math that we did previously, we said that an object that fell for 1 second would have gained 10 meters per second of velocity, and an object that fell for 2 seconds would have gained 20 meters per second of velocity, and so forth. We may also be asked to find out how far the object fell within a certain amount of time. The calculation for this one is a little bit more difficult, but definitely doable. I will now show you how to derive the equation for the displacement of a dropped object. So we know that velocity, or average velocity, is simply the displacement divided by the time it took for the object to undergo the displacement. If we wanted to find the average test score between 3 students, we would add their test scores and divide by 3. If we wanted to find the average velocity of a falling object, we can take its first velocity or initial velocity and its final velocity and divide by 2. So instead of the average velocity, we write the sum of the initial and final velocities divided by 2. We typically look at objects that are dropped from rest, so we know that the initial velocity is going to be equal to 0. So therefore, we can further simplify this equation. And then we can also multiply over the time, so we just get displacement by itself. We know from the previous slide that to calculate the final velocity of an object in free fall is just simply the gravity multiplied by the time. And we can plug in this relationship into the previous equation that we had. And we end up with this equation, which we can further simplify. And we see that if we want to find the displacement of an object that's in free fall, it's simply equal to 1/2 times gravity times time squared.